Okay, so now that we have completed quadratic function, finding the vertex of a parabola, looking for the maximum or minimum, or finding the y-intercept, here in the new chapter, we are going to look at quadratic equations. So what is the difference between quadratic function and quadratic equation? Quadratic function gives us a parabola when you draw it out. It consists of some x value and it consists of the y value. And that's why you see your equation in y equals something like this. But when it comes to quadratic equation doesn't work with x and y at the same time. Quadratic equation will only work with the x value, which means you are not looking for the vertex. It is not x and y for the vertex. It is not finding the y-intercept anymore. We are trying to figure out the value for x. So technically, when you are to solve your equation, what is the value for x? It is the x-intercept on your parabola. For your parabola, it is the root of your quadratic equation. So when you are solving a quadratic equation, we are finding the value of x, we are finding the answer for x, we are finding the root of a quadratic equation. But if you choose to graph it, you're still going to see a parabola. You're just not looking at the vertex anymore. We are looking at the x-intercept. So in the previous unit, we've seen quite a few parabolas. We've seen a lot of parabolas. Some of them will have its parabola not touching the x-axis at all, and that means there is no x-intercept. There is nothing here. Your parabola doesn't go across the x-axis. So we call it no real roots, no answer for x. There are times when you see your parabola touching the x-axis once. So you're basically talking about a regular parabola, a parabola that looks like this, but you are not moving the parabola up or down. You're only switching your parabola sideways, changing the vertex for the x-coordinate of the vertex. So you only see one real root for your parabola, and that means you only have one answer for x, for whatever x value it is. Maybe x equals 4. Just randomly selecting some numbers. But more often, you will see your parabola going across the x-axis twice, giving us zeros at two different points. You may see parabola opens up. Sometimes we have parabola that opens the other way, and in this case, we are still getting two zeros for the parabola. So we call it two roots. You have one answer here, and you have another answer here. Whether you have your parabola opens up or have your parabola opens down, you have one answer here, and then you have another answer there. So this is the major difference between a quadratic function, where you work with the vertex, or quadratic equation, where you find the x-intercept, So looking at example number 1, if I have 3 different parabolas here, if I want to figure out the number of roots for each parabola, I'm basically counting the number of times the parabola touch the x-axis. So in this case, we will have one root. And this one root, by just looking at the graph, we have x equals -5. And this is the root for equation -x² minus 10x minus 25 equals 0. Using the graph for this quadratic function, we can then work with its quadratic equation having an equal sign. And this equation will help us to solve for x. Your x value would be the point where your parabola intersects the x-axis. So for the next one, I have two roots. I have one root at -2, and I have another root at +2. And that means if I'm to solve the equation that involves x squared minus 4 equals 0, solving for x, you will see these two numbers here. Now, some of you probably have already started to recognize that these two numbers for x are actually from your equation. Seeing how we have x squared minus 4 equals 0.